ways to integrate. So we have our chapter 5 techniques that we've worked with, and so now we're just going to add to that. So our first technique that we're going to be working with is what we call integration by parts, and I'll abbreviate that oftentimes with this whole IBP. And really this is undoing our product rule. So if we had a product rule, how would I undo that, right? So the derivative, so let's go over that. So if I had u times v, where u and v are both functions of x, and I want to take that derivative, right? So that derivative would be 1, and then times d2, so v prime, plus 2, which is v, times the derivative of u, which is u prime. So if I want to figure out, okay, well, how do I, given this right-hand side, how do I get back to kind of that product rule idea? And so how do we undo a derivative? We integrate it. So if I take a look at that, then this component over here, so if I integrate this, I'm going to be a little bit lazy with my notation right here and integrate this side over here. So we'll do this with respect to x. So the integral of the derivative would just be u and then v, right? So if I took the derivative and then the antiderivative, I would just get uv back. And then this over here, I would say, all right, so this is the integral of u and then v prime, which is dv over dx, so that would be dv, and then distribute the integral into there, so plus the integral of v, and then u prime, which is du over dx times dx, which would be du, right? So then this component right here, so if I take a look at actually what is the integration by parts, so this piece right here, so that is just isolating this udv. So we're integrating a piece at a time, meaning I don't necessarily know how to integrate this if I have this all together, but if I took the integral of just a component, right, then that would get me to the end. And so in this case, we are just choosing to integrate that and use that as our integral, and then subtract this to the other side. So I would have u times v minus the integral of v du. So again, so integration by parts is just undoing product rule, but we're integrating only one piece at a time. So we have to get to, okay, what is this integral? And then what is that integral, right? So that's essentially what we're doing. That's like kind of the big idea. And so again, if any of that never makes sense when I talk about where it's coming from, that's okay. So the way we have to look at it is this is just a pattern that I need to memorize. So these tips right here are going to come into play and be very important for us later on. So our first thing we want to do is figure out, okay, so this is what I will be given, and I need to turn it into this over here. And so I will still have to integrate this. So I'll have 2 steps of integration. That's hence the name integration by parts, meaning a piece at a time. So we'll always figure out, okay, what am I going to call u? So when I split the integral, like what am I going to call u? And then I will have to differentiate that to find du. And then whatever I didn't call u will now become my dv, and then I have to integrate that to find b. So I'll have an integral component here. So this is just the tip here. So we typically want to choose dv first because finding an integral is more challenging than finding a derivative. So we will choose our dv first, and we'll let it be the piece that looks the most complicated, but we still have to actually know how to integrate it. And so most of the time that will work, but that is not an always. So that is definitely not an always. All right, so let's go ahead and take a look at this first one. And so off to the side here, we'll talk about, so what are my steps in order to integrate this? So for starters, how do I even know that I'm doing integration by parts? Because it's not a pattern or UDU that will fit into a chapter 5 technique. But also another way is that if you look here, you have x and e to the x, right? So typically you would have a polynomial, so like x squared, 2x plus 1, that sort of thing. And then something that's not a polynomial, so like a transcendental function, so like e to the x, sine x, ln of x, that sort of thing. And that also tells you, oh, I probably have integration by parts. Okay, so let's go over our steps. So the first thing we want to do is we want to figure out how are we going to split up that integral. So we want to split it up, the integral, and we want to do that into two parts. And so that would be, what am I going to call u and what am I going to call dv? So I typically find the dv piece first. So again, the dv is what looks complicated, but we know how to integrate it. And then once I choose the dv component, keeping in mind that the dx will go with it, everything else I did not choose for my dv will be u, okay? All right, so that's my first step. So if I look over here, I have this whole thing x times e to the x times dx. So for sure, the dx has to go with the dv, but then I have to decide, do I want the x over there or do I want the e to the x? And so what I think is most complicated looking anyways, which is not just basic power rule, would be the e to the x. So I would go for e to the x and dx to be what I call dv. So if this part is going to go over here to dv, then the remaining term, which is x, has to be u. So before I find anything else, I need to know, okay, well, do I actually know how to integrate this? Do I know e to the x dx? Okay, and so yes, I do. That's a pattern from chapter 5. So excellent. So then I'm going to move on to step 2 because I do know how to integrate that, right? So then step 2 is I'm going to actually find both of those pieces. So then find du by taking the derivative of u. And then we're going to, and you can do steps 2 and 3 interchangeably, do them all together. I'm just writing them as 2 and 3, but again, you can flip that around and go any order. And so then now we find v by finding the integral of dv. And so I'm just going to do integral of dv. Okay. All right. So I know the derivative of x is 1x to the 0, which is just 1. And then the integral of e to the x dx is just e to the x. And we'll have a plus c that will come into play in a little bit, okay? So then our step 4 is now we're going to use the rule above, okay? So we're going to use the rule above and we're going to set up the second and final part of integration by parts. So we already did an integral once, right? This was this step right here. So we found that integral once. So we did the first part of the integral. So now we're going to set up IBP. So remember that stands for integration by parts. And find the second and last integral, hopefully, and find the integral. Oops. From the IBP pattern. Okay. All right. So I'm looking up here right now. So let me switch out of that. So I'm looking up here and I'm just going to follow this pattern. Okay, so that's what I want to do. So this is my integral of what I called udv, and so I'm just going to do that down below here. So the integral of x e to the x dx is equal to, now I need to do the product of u and v. So here is u and here is v. So x times e to the x, and then minus the integral of v du. So the integral of v, which is e to the x, and then du, which is 1, and I realized I forgot my dx here. So 1 dx, so times 1, and then dx. So I did the setup part, so now I'm done with that. So now I need to find the integral from your IBP. So that would be this component over here, so the integral of e to the x. So that would just give me x e to the x. I'm just copying that down. And then the integral of e to the x is just e to the x. And then, of course, plus c. Okay. All right. So there, I'm done, right? Because I've got no more integrals left. Okay. So far, so good. And of course, I can always check that by taking that derivative and see if I get x e to the x. All right. So let's take a look at part B. So the first thing I do for part B is I know the dx, of course, has to go with the dv. And so then now I have two pieces here, x and then ln of x plus 1. And I have to decide, okay, which one do I want to go with the dv? And again, I always try that first. So I would say, well, the natural log looks most complicated, right? So that would be the natural log of x plus 1 dx. And so then the piece that I didn't use is x, so that would go for u. So then again, now before I go much further, I have to say, all right, so do I know the integral of natural log? So if I look through that pattern, or that list of patterns, I don't have a single pattern that says what is the integral of ln of u, right? So if you go and you look at your pattern sheet, is that on there? And it's not. So yeah, that's the most complicated piece, but the problem is that that doesn't help me out because I don't know that integral, right? So whatever I choose for dv, I have to know the integral from. So it has to be one of those chapter 5 or chapter 3 patterns, or chapter 4 and 5 patterns. All right. So I didn't know that integral. So then now, all right, I'm going to have that be my u. So I'm going to then flip-flop because that didn't work for me. So I'll leave natural log of x plus 1 to be for u, and then the piece that are going to be remaining are x and dx. All right, so once I split that integral up, now I need to go and find the different pieces. So I need to take this derivative. So the derivative of a natural log is what follows the natural log in the denominator, its derivative in the numerator, and then I won't forget my dx this time. And then the integral of x to the first would just be x squared over 2, or 1/2 x squared. And I'll catch my plus c on the second integral. So then once I get to there, then I'm going to go ahead and follow and use that pattern, right? So I have the integral of my original question, so x times ln of x plus 1 dx. And so that's going to equal to u times v, so I'm going to multiply those two together. So 1/2 x squared ln of x plus 1, so there's my u times v, and then minus the integral of v times du. So that 1/2 I'm just going to pull to the front because it's a coefficient. So then I have x squared times 1 over x plus 1. So that would just be over x plus 1 and then dx. Okay, so then now I have to integrate this. So how do I do that part? Okay, so that integral, so if I look over here, so we practiced a little bit of this in 7.1, hopefully, is an improper fraction, right? So I have that x squared on top and that x plus 1 on the bottom. So I'm going to do long division or synthetic division or, something fancy, however you want to do that. So I'm just going to do long division. So what would I multiply x by to get x squared? That would be x, and then distribute to both. So that would be x squared plus 1x. So I'm going to put a 0x up here. And then subtract, so that would be 0, and that would give me negative 1x. What do I need to multiply x by to get negative 1x? And that would be negative 1. And then now distribute, so that would be negative 1x minus 1, and I'll put a plus 0 up here. And then subtract, so that'll turn into positive, and so I have a remainder of 1. So then what I have here is I have that 1/2 x squared, natural log of x plus 1, and then minus, don't forget I have that 1/2 here. And then I'm going to rewrite that division problem to be x minus 1. And then my remainder of 1, it means I'm going to do plus my remainder, and then what I divided by. And so I'm going to do that as two separate integrals, right? So we would have, our x minus 1 is one of the integrals, and then that's with respect to x, and then plus my other, or my remainder, sorry, which is 1 over x plus 1, and then dx. And then just so I don't mess that up, I'm going to group that because that negative 1/2 is for both of those pieces there. All right, and then last step is now that I did my long division, I can go ahead and integrate. And so this would be a good time to, maybe press pause and try to do the integral yourself here, okay? So then that would be 1/2, and then the integral of x is x squared, and then minus integral of 1, which is 1x or x, and then plus, and then this is a natural log, because the derivative of x plus 1 in the denominator is equal to 1, which is the numerator. And then, of course, I can distribute and do other kinds of things, or just go ta-da. And I'm just going to go ta-da. We'll call that good. All right, so let's go ahead and take a look at a couple more here. Okay, so you may want to, try to press pause and see if you can figure out at the very least like what your u and your du are. and see if you can go from there. And I think I'm going to actually, yeah, let me go ahead and do this one. Okay, I was going to flip-flop C and D, but I'll go ahead and do C first. So this one is, there's a lot here, right? There's a lot. So I have a lot of choices as far as how I would want to integrate this. So one of the things that I could certainly do, let's see here. I'm going to split this apart just so I can see this a little better. So this would be x times e to the x times, and then pull that denominator up, x plus 1 to the negative 2. And then keep in mind that, all of these are being multiplied. So I have way too many choices right here for what I would want to let dv be. So for starters, I can certainly integrate x, so that could be dv. I can integrate e to the x, that could be dv. And I can also integrate x plus 1 to the negative 2, right? So I can do all of those for my dv. So I definitely don't want to try the x first because that isn't complicated, so to speak, right? So I could let it be e to the x, right? So I could say, all right, I'm going to let that be e to the x and that dx. And then my u I'll do as x and x plus 1 to the negative 2. So again, just trying this out first and see if I can get anywhere. So the integral of e to the x is just going to be e to the x, and then this derivative is going to be a fun little product rule, right? So this would be 1 d2 plus 2 d1. So I would have 1 and then d2, so negative 2, x plus 1 to the negative 3, and then plus x plus 1 to the negative 2, running out of room, times the derivative of x, which is 1, and then all of that is dx. So when I look at this, I think, oh, geez, I don't know how much better that's going to look. But so I'm just going to do a quick little scribble down and see if I can come up with anything. So this would be u times v, right? So I would have u and then times v, and then minus the integral of v and then du. And I'm going to go ahead and rewrite this just a little bit. So I would have negative 2x over x plus 1 cubed, and then plus 1 over x plus 1 to the negative 2. And I look at this and I have like a big old frown and probably some tears because the thought of trying to integrate this, I'm getting chills. Like I look at that and I'm like, oh, do I know how to integrate that? I don't think I do. So I'm going to I'm going to pass on that. Like maybe that was right. Maybe that's what I should be doing. But I think I'm going to try something different because that does not look promising. And that's one of the great things about doing this technology-wise is it's so nice to erase, right? I don't need to actually get dusty eraser everywhere. All right, so that didn't work. So then I need to try something different. And I don't know that it didn't work. It just didn't look good. Like that's the point I want to make. All right, so let's try something else. So the e to the x was bad news everywhere. So then let's try the other piece that was complicated. And I'm going to try x plus 1 to the negative 2 over here. And then the remaining parts x e to the x for u. And then cross my fingers on this one. So still not lovely because it's product rule, but it's a little bit more lovely, I think. I don't know. All right, so product rule here. So 1 d2 plus 2 d1, and then I'll remember the dx. And then this integral would just be, what is that? X plus 1 to the negative 1 divided by negative 1. And then that derivative is 1, so I don't have to worry about chain rule on that. All right, so here we go. So we have u times v, so I'm going to multiply these two together, and then I'm going to rewrite that just to make it a little easier. So there's my u, and then times v, so negative 1 over x plus 1, right? So I just pulled that down. And then, so u times v, and then minus the integral of v times du. So multiply these two together. So v times du. So that would be negative 1 over x plus 1, and then times, let me group this out, x e to the x plus e to the x all over times dx. Okay. So I look at this and I'm like, ooh, yeah, that doesn't look much better, but it does look a little better. So I'm going to actually fuss with this one a little bit to see if I can make it work. So let's just do a little bit of a rewrite. So I'm going to multiply those together. So that would be -1 times that. So -x e to the x over x plus 1. I have that double negative, which is a plus. And then this is my numerator, right? So x e to the x plus e to the x over x plus 1, and then dx. So if you haven't pressed pause and weren't trying this, this would be a good time to do that, because this is definitely an integral that you should be able to do, even if you don't recognize it like right away. Okay, so it should be an integral you should do. All right, so let me point something out here. So what do these have common here? They both have an e to the x. So that means I can factor out that e to the x, right? So when I do that, I'll be left with x here at plus 1. And then I still have that all over x plus 1 dx. And so when I do factor that out, then these will reduce. And so then what I'm left with is something very easy to integrate, right? So I'm left with the integral of e to the x dx, which is just e to the x plus c. And there you have it. A very tricky problem. Well, all of them have been tricky, but that one in particular, really tricky. All right, so let's go ahead and try this last one here. So for D, so I want to integrate this. So again, I want to choose something for, dv. What am I going to let dv equal? So, well, I certainly could let it be arc sine of x, sure, right? And then what do I have left over here? I got nothing, right? I got a 1. Okay, so absolutely not helpful, right? Because then if I knew the integral of arc sine of x dx, why would I be even using integration by parts? So that's a bust. So then now I need to flip that to the other side. So instead, all right, so let's throw the u over here. So that would be arc sine. And then what would be remaining is dx. But remember, I'll be integrating 1 with respect to x. All right, so the derivative of arc sine, so that would be 1 over, and then the square root of 1 minus x squared, and then dx. So if you don't know these, make sure you always have that list out so you can look them up, right? And then the integral of 1 with respect to x is just x. So then let's go ahead and integrate. This time we have a definite integral, right? So we're going from 0 to 1. So then let me just do that off to the side over here. So then I have u times v, so u times v, so that would be x, and then arc sine of x, but we're integrating from 0 to 1, right? Because that's the integral component of that one piece, so I have to have that brackets on there, right? So u times v, and then integral from 0 to 1, and then minus the integral of v times du. So v, which is x, and then times du. Okay, so I have, I'm going to do a rewrite on this one over here and then substitute limits into here. So I'm going to put in 1 first. So that would be 1 times arc sine of 1 minus, and then 0 times arc sine of 0 would still be 0. So I'm just going to write that as a 0. And then I'm going to move that up to the numerator. Okay, so then from here, I know that I could just do a UDU, right? So that'll just be a UDU substitution. So I would let u equal the inside, so that would be 1 minus x squared. And then that derivative would be negative 2x dx. And then I only have an x dx, so I'm going to divide both sides by negative 2. And so I have 1 times arc sine of 1. So arc sine of 1, so just off to the side over here. So this is asking, just a reminder, at what angle does sine equal 1, right? So at what angle does sine equal 1? And so that's the y value. So that would be at pi over 2. So then this would just be 1 times pi over 2, which would just be pi over 2, and then of course minus 0. And then minus the integral, and so I would replace this with u, so I'm back over to here, to the negative 1/2. And then x and dx are going to be replaced with du over negative 2, but I'll pull that out. So that would be a negative 1/2, which would turn positive. And then remember, these are values of x over here, but I need them to be in terms of u, right? Because I'm with respect to u. So when x is 0, that would be 1 minus 0, which is 1. And when x is 1, I'd get 1 minus 1 squared, which is 0. And then let's go ahead and do power rule there. So that would be u to the positive 1/2. And then dividing by 1/2 is the same as multiplying by 2. And then again, I'm going from 1 to 0, which seems kind of weird, right? Because we're upside down there. That's all right. That's okay. So I still have that pi over 2, and then 1/2 of 2, which is just 1. So that just reduces down to 1. And then substitute in 0. So that would be 0 to the 1/2. And then minus, substitute in 1. So 1 to the 1/2. So that would be the square root of 0, which is 0, and the square root of 1, which is 1. So pi over 2 minus 1. Right? So the integration by parts component wasn't that painful, but a lot of limits going on there. Okay, and that is the end of